Systems of linear equations in two variables. If 2 adult tickets and 1 child ticket cost $32, and 1 adult ticket and 3 child tickets cost $36, what is the price of each? This is an example where we have two variables, adult tickets and child tickets, and we want to figure out the price of each individual ticket. So first we're going to define our variables. So we're going to let x equal the price of an adult ticket and y equal the price of a child ticket. And then we're going to use the things that we're given. So 2 adult tickets and 1 child ticket cost $32. So 2x plus y is 32. 1 adult ticket and 3 child tickets cost $36. So x plus 3y is 36. So this is the system of linear equations, and we're going to talk about how to solve these using three methods: graphing, substitution, and elimination. One thing that we should note is that 16-0 solves the first equation, but not the second. 24-4 solves the second, but not the first. So when we use these methods to solve, what we're actually going to need to find are all the ordered pairs of real numbers that satisfy both equations at the same time, and that is going to be called the solution set. So this is just the formal definition of what we just talked about. So feel free to pause and read this. Notice at the bottom, the last sentence is very important. Linear systems can have one solution, no solution, or infinitely many solutions. And we're going to look at some of these cases. So first we're going to solve by graphing. So say we have 4x minus y equals 2 and x plus 2y equals 5. So there's two different ways that we can solve. One way is we can graph the two equations using the x and y intercepts and then find the points where they intersect. Another way that you could do this is you could use y equals mx plus b. That would allow you to find the y-intercept, and then you would just use the slope, or the number in front of the x, when you solve for y, to know how far to go up or down and left or right. So either method is perfectly fine. Here I chose to use the x and y intercepts. So for 4x minus y equals 2, to find the x-intercept, that's where you cross the x-axis. That means that y is 0. So we get 4x equals 2, so x ends up being 2/4 or 1/2. So 1/2, 0 is an ordered pair on our graph. The y-intercept is where the line crosses the y-axis, so x is 0. So we have negative y equals 2, so y is negative 2. So 0, negative 2 is another point, and 2 points make up the line. The same process for x plus 2y equals 5/2. If we let y equal 0, we get x equals 5, so 5, 0 is a point we plot. And when x equals 0, 2y equals 5 gives us 0, 5/2, which is really about 0, 2.5. Now, this could be a good example of when slope-intercept form could come in handy. Sometimes on your homework software, it won't let you graph decimals, and so if you did it with the y equals mx plus b, that could make things a little simpler for you. So now that we have our lines graphed, we want to look for where they intersect. So notice they intersect at the point 1, 2. So that means the solution is just one ordered pair with x being 1 and y being 2. So let's look at another example. 2x minus 3y is 12 and 4x minus 6y is negative 24. So if we look at the x and y intercepts, for the first one, When y is 0, we end up 2x equals 12, so x is 6, so we can plot 6, 0. And when x is 0, we can find the y-intercept using negative 3y equals 12. So 0, negative 4 is the other point on the line. Using the second equation, finding the intercepts, the x-intercept is when y is 0, and we get 4x is negative 24, so x is negative 6, and that means that negative 6, 0 is a point on our line. To get another point on our line, we're going to find the y-intercept. So we let x be 0. That gives us negative 6y is negative 24, so y is 4. So 0, 4 is another ordered pair. Notice that these two lines don't intersect anywhere. If your two lines do not intersect, that means you have no solution. Now, what if our lines were on top of each other? If the lines intersected everywhere, that would be where you have infinitely many solutions. It would basically mean that the lines are just multiples of each other. So now let's look at substitution. Substitution means that you're going to take one of the equations and you're going to solve it for a variable. You're going to substitute that into the other equation, and that'll help you get one variable, and that you can use that to find the other. So I chose to solve for x in the first equation, x minus y equals 5. So that gave me x equals 5 plus y. Next, I substituted 5 plus y in for x into that second equation. So I have 3. Remember, x is now 5 plus y, so 3 times 5 plus y, plus 5y equals negative 49. That gives me 15 plus 3y plus 5y is negative 49. So 8y is negative 64, meaning that y is negative 8. So now I know one of my variables, and I can use that to find the other. I know that x is 5 plus y, so I'm going to substitute y equals negative 8 into that to find x. So x is 5 minus 8, so x is negative 3. So remember, our ordered pairs are always written x comma y, so negative 3 comma negative 8 is the solution. Another method is to solve using elimination by addition, or some people call this the addition method. In this method, what we want to do is we want to multiply one of the equations, or sometimes both of the equations, by something that will allow us to cancel one of the variables out when we add them together. So if we look at 3x minus 2y equals 30, and 5x plus 3y equals 12, I chose to get rid of the x's. So I'm going to multiply the first by 5 and the second by negative 3. And you can see here why I did that, because I ended up with 15x minus 10y equals 150, and the second equation is negative 15x minus 9y is negative 36. So 15x will cancel the negative 15x. So negative 19y is 114, so y is negative 6. And now I can choose either equation I want. I'm going to go back to the originals before I multiply by anything. Choose either one and substitute the negative 6 in for y. So I chose to use the first equation. So I had 3x minus 2 times negative 6 equals 30. And after I performed my algebra steps, I ended up with x equals 6. So 6, negative 6 was my solution. And if this is my solution, I should be able to take 6 for x and negative 6 for y, enter those in to both equations, and have a true statement. 30 equals 30 and 12 equals 12. So for this problem, we're told that we can do this by substitution or elimination by addition. Personally, I usually do elimination by addition unless one of my variables is easy to solve for or is already by itself. In this case, I see that I have a 5x and a negative 10x, so I see that I could multiply the first equation by 2 to get 10x, and then when I add them together, that would cancel the x's out. So that's what I chose to do. So I had 10x minus 8y equals 8, plus negative 10x plus 8y is negative 8, so I end up with 0 equals 0. Now, that is always a true statement. 0 is always 0, 5 is always 5, 7 is always 7. When we get a true statement like this, that means that we have infinitely many solutions. So let's think about an example where we would have no solutions. Well, that would be when you get an untrue statement, something like 0 equals 1 or 5 equals 3. That is not true, so if you were to solve a system and get something like that, you would have no solution.